Hi, good evening. This is Sathyamoorthy, verified CAD educator in the Unacademy platform. Hi, good evening to all. This is Sathyamoorthy, verified plus educator in the Unacademy platform. Today, we are discussing about the higher order differential equations part 2 in the subject of engineering mathematics for the GATE aspirants who are all appearing for the mechanical engineering examination as well as other streams, because the differential equation is common for the all the branches. Okay, this is my code, Unacademy code, referral code. Use code Moorthy536 to get 10% discounts in the Unacademy subscription. Okay, you can get minimum of 10% discounts by using this code while subscribing into the Unacademy platform. Yes. Coming to the discussion. Okay. We know that the differential equation, again I am giving the differential equation things here. Higher order differential equation, these are the things. Today we are discussing about the higher order linear differential equations with constant coefficients. General form of the linear differential equation of the nth order with constant coefficient is given by dn power y divided by dx power n plus k1 into d power n minus 1 into y divided by dx power n minus 1 plus k2 into d power n minus 2 into y divided by dx power n minus 2. Okay, up to the orders we are increasing here. K1, K2, Kn are the constant used here. We are substituting n is equal to 2. It may be a second order. We are substituting n is equal to 2 in this equation. Then here 2 minus 1. Here 2 minus 2. So up to the power 0 we are getting. So the n is equal to 2. It is called as second order linear differential equation. Second order linear differential equation. What we are doing here, we have to replace the equation d divided by dx. Here the operation d divided by dx is replaced by a single letter, that is called as differential operator, capital D. Here dy divided by dx is replaced by capital D into y, and then d square y divided by dx square is equal to capital D square into y. So these are the substitutions we are doing here. D cube y divided by dx cube is equal to d cube into y. Generally the differential equation term d power n y divided by dx power n is equal to capital D power n into y, because here the term capital D stands for the differential operator. Right. This is a general form of the linear equations of the second order. When you are substituting n is equal to 2, as per the previous slide discussion, we are substituting n is equal to 2, d square y divided by dx power 2 plus k1 into d power n minus 1. Here n is equal to 2, so dy divided by dx. The equation is converted into second order equation. So d square y divided by dx square plus p into dy divided by dx plus q into y is equal to r. So general form of the differential equation. Here we are substituting d divided by dx is equal to capital D. So d square y divided by dx square is equal to d square into y. Then plus here p into d. Here p the constant term, constant coefficients, into dy. D divided by dx is replaced by capital D. So dy divided by dx is equal to capital D into y, plus q into y is equal to r. Stands for operation of differential. Then 1 divided by d stands for the operation of integration. These are the very important notations we are using during the problem solving procedure. Okay, here d, the multiplication of differential operator, stands for differentiation, and 1 divided by d stands for the integration of the given differential equation. The complete solution, y is equal to complementary function plus particular integral. The complementary function is solution to the RHS of the given differential equation. Then particular integral is the solution to the given differential equation RHS side. Okay, so particular integral plus complementary function is the complete solution for the differential equation. Next we are moving into the next one. The complementary solution, already we have discussed the complementary solution. So complementary function for the second order differential equation. These are the three categories. When roots are real and different, it means m1 and m2 are real values but not equal to m2. m1 is not equal to m2. The complementary function is a into e power m1 x plus b into e power m2x. Roots are real and equal category. The roots are real value also equal. It may be a 1 equal to 1 or 2 2 minus 1 1 minus 2 2. Roots are real and equal value. For this category we are using complementary function ax plus b into e power mx. Then roots are imaginary, that is alpha plus or minus beta I. Then complementary function e power alpha x into a into cos beta x plus b into sin beta x. Then particular integral, these are the particular integral category. The formula for the particular integral is equal to 1 divided by f of d. The function depends upon the variable d, that is the LHS of the given differential equation, into x. Here x is e power ax, sin ax or cos ax, or x power n, then e power ax. Based on this 4 formulas, we are having 8 cases. These are the different cases. Problems based on higher order linear differential equations with constant coefficients. Case 1, RHS is equal to 0. Case 2, RHS is equal to e power ax. Case 3, RHS is equal to sin ax or cos ax. Then case 4, RHS is equal to x power n. Case 5, RHS is equal to e power ax into ax plus sin ax or e power ax plus cos ax. Case 6, RH is equal to e power ax into the case 2 into case 3, a combination of case 2 and case 3, e power ax into sin ax or e power ax into cos ax. Then case 7, RH is equal to e power ax into case 2 and 4, e power ax into x power n. The 8 categories are totally different. X power n into sin ax. It has different formula to derive the complementary function as well as particular integral. Okay, we will discuss these things one by one. In the previous classes, it's a part 3. Already in the part 1 and 2, we had a very good discussions about the RH is equal to 0 format. We had a few multiple choice question, practice question as well as previous year gate question. Then today we are moving into the case 2. Already we had a discussion about the case 2. Again I am giving the revision to the case 2. Then we are moving into the multiple choice question format in the case 2. After completing the case 2, we are moving into the case 3. In the subsequent classes in the YouTube live classes, I am going to handle these cases, 8 different cases as well as Euler-Koch equation. Before entering into the topic, okay, please follow my name Sathyamoorthy space V in the Unacademy learning app. Okay, search my name in the search bar in the Unacademy learning app, Sathyamoorthy space V. Then follow me. Then you get notified during the each classes, special classes as well as regular classes. Okay. Then e power ax category, coming to the e power ax. When e power ax is the right hand side, then it's a formula for the e power ax. When we are having e power ax in the right hand side, this is the procedure, particular integral. 1 divided by f of t into e power ax is equal to e power ax divided by 1 divided by f of a. Here what we are doing here, we have to keep this e power ax in the front side. Then we have to substitute constant a instead of d, letter d in the denominator. After substituting this value, the f of a in the denominator should not equal to 0. If f of a is equal to 0, the 1 divided by 0 is infinity. So ordinary rules fails. So we have to again change the procedure here. The thing is, we have to multiply when f of a is equal to 0. After substituting a instead of d in the denominator, f of a is equal to 0. Then we have to multiply the x in the numerator. Then we have to differentiate the f of d in the previous case one time with respect to the d. Again the condition should be f dash of a after again substituting the a constant a instead of d. The condition is the f dash of a should not equal to 0. If f dash of a is equal to 0, again we have to follow the same procedure what we did in the previous case. Again we have to multiply the x here, then again we have to differentiate second time the denominator. Okay, this is the procedure. Next we are moving into the discussion on the e power ax format as per the multiple choice questions. Yes, e power ax category. This is the e power ax category. Here d square minus 4d plus 13 into y is equal to e power 2x. Already we had a discussion about this problem in the previous class. Again I am giving the revision. Then we are moving into the multiple choice questions. Okay. Here first we need to identify the complementary function, then particular integral, because the total solution is, it's a combination of we know that the solution of the differential equation is the both complementary function plus particular integral. Okay, complementary function is the solution to the LHS, particular integral solution to the RHS. So coming to the explanation for the problem here, first we need to identify the complementary solution. Okay, before coming to the complementary solution, we have to identify the root values for the given differential equation. It's a second order differential equation. Here the letter D is replaced by another notation m, because here D stands for the differential operator. That's why we are changing the name. M square minus 4m plus 13 is equal to 0. The root value, we know that the root value m is equal to 4 into plus or minus b plus or minus root of b square minus 4ac divided by 2a. Here minus b is equal to minus of minus 4 plus 4 plus or minus root of b square. Here b square is equal to minus 4 square 16 minus 4ac. 4 into a 1, 4 into 1 into c 13, 4 into 1 into 13 equal to 52 divided by 2 into a. Here 2 into a, we know that a coefficient of m square is 1, then 16 minus 52 is equal to minus 36. Here take the 36 from the root, so we are getting 6 from this equation. We are taking 36 outside. 4 plus or minus 6 into root minus 1. Root minus 1 is divided by 2. Root minus 1 is equal to I. So 4 plus or minus 6i divided by 2. So as per the procedure, 4 divided by 2, 2. Again 6 divided by 2 is equal to 3. So 2 plus or minus 3i. 2 plus or minus 3i. Then as per the discussion in the complementary table, coming to the complementary table, this is a complementary function and the root values are imaginary value. If you are having the I in the root value, it is in the category of imaginary. For the imaginary case, alpha plus or minus beta I. Then e power alpha x into a into cos beta x plus b into sin beta x. So this is a procedure here. Then roots are imaginary in this condition. 2 plus or minus 3a in the given problem. So from this equation, we are writing the complementary solution. So complementary function is equal to e power alpha x. Here alpha is equal to 2 into a into cos beta x. Here beta is equal to 3 plus sin 3x. So beta 3 a e power ax into a cos 3x plus b sin 3x. This is the function here, complementary function. Then particular integral. Particular integral pi is equal to 1 divided by d square, 1 divided by f of d into e power ax. Here f of d is equal to the left hand side. F of d is equal to d square minus 4d plus 13 into y divided by e power 2x. So this is the condition. Then here what we are doing here, e power ax, we have to replace the d square by here letter d by a. This is the procedure. So we are substituting instead of letter capital D, number 2. So d square, 2 square is equal to 4 minus 4 into 2 is equal to minus 8 plus 13. So e power into 2x. 4 minus 8 plus 13 is equal to 9. So 1 divided by 9 into e power 2x. This is the procedure here. Y is equal to complementary function plus particular integral. Here the complementary function, this solution, plus particular integral is equal to 1 divided by 9 into e power 2x. Then we are moving into the multiple choice questions as per the discussions. We are coming to the multiple choice question. Yes, here multiple choice questions for the e power ax format. Here d square plus 4d plus 8 into y is equal to e power 2x is. These are the four options. Okay, now we are going to identify the solution for the given differential equation. Based on the differential equation, we the particular integral as per the discussions from the previous cases. Particular integral is equal to pi is equal to 1 divided by f of d into e power ax. 1 divided by f of d into e power its ax. So here f of d is equal to left hand side of the differential equation. So 1 divided by d square, f of d is equal to d square plus 4d plus 8 into e power 2x. Here the a is equal to 2. We have to substitute number 2 instead of d. So here what we are doing here, d square is equal to 2. 2 square plus 4 into d is equal to 2. 4 into 2 plus 8 into e power 2x into e power 2x. This is a procedure here. Then the solution is equal to 2 square is equal to 4. 4 plus here 4 into 8. 4 plus 8 12. 12 plus 8 20. So 1 divided by e power 2x. E power 2x. This is the solution for the given equation. Yes. Option B is the correct answer because 1 divided by here 1 divided by 20 into e power 2x is the solution for the given differential equation. Okay, Linus, I am giving the one by one questions. Okay, try it and give your answers in the live chat. Okay, then again I am discussing the answer for the question. The next question to you guys. Yes, this is the next question. The particular integral of d minus 2 the whole square into y is equal to e power 2x is. Okay, what is the solution for the given equation? Okay, coming to the solution, the particular integral, we know that the particular integral is equal to pi is equal to, again pi is equal to f of d 1 divided by f of d into e power ax. F of d into e power ax. So coming to this equation, 1 divided by f of d is equal to d minus 2 the whole square into e power 2x. Here we have to replace the letter d by number 2. So is equal to 1 divided by 2 minus 2 the whole square into e power 2x. So this is the procedure here. We are replacing 2. What we are getting here? 1 divided by 0. 1 divided by 0. When 1 divided by 0, the ordinary rules fails. And the denominator is equal to 0. Here ordinary rule fails. As per the discussion, ordinary rules fails. Ordinary rule fails. So when the ordinary rule fails, okay, we have to change the procedure here. Okay, already we had a discussions about the particular integral. Here particular integral is equal to, when coming to this slide, the particular integral for the given problems, when f of a is equal to 0 in the denominator, that is after substituting the letter a constant a instead of letter d, here f of a is equal to 0, then we have to multiply the x in the numerator, then we have to differentiate the f of d one times with respect to the d. So as per the procedure, coming to the problem, yes, Here we have to differentiate the f of d one time, then we have to multiply x in the numerator. Multiply the x in the numerator is equal to x into 1 divided by 2 minus 2 the whole square, 2 into d minus 2, d minus 2, again differentiation of d is equal to 1, into 1 is same answer, into e power 2x. Again substitute the same procedure, again substitute the equation, instead of 2 d, x into 1 divided by 2 minus 2, 2 minus 2, 2 into 2 minus 2 into e power ax. Again the denominator is equal to f dash of a is equal to r0, 1 divided by 0 into e power 2x. Again f dash of a, coming to the procedure, again f dash of a is equal to 0 in the denominator. The condition should be after multiplying the x, after differentiating the denominator one time, the condition is the f dash of a should not be equal to 0, but f dash of a is equal to 0. If f dash of a equal to 0, then what we are doing, again we have to multiply the x in the numerator, again second time we have to differentiate the denominator one time with respect to the d, f double dash of a. So in this procedure, yes, again differentiate one time, again when you are differentiating this value, what we are getting here is equal to, again x into x, x square, x into x, x square, then multiply the d inside. So here 1 divided by 2 into differentiation of d is equal to 1, differentiation of minus 2 is equal to 0. So 1 divided by 2 into e power 2x. So this is the solution as per the discussion is equal to, here x square divided by 2 into e power 2x, into e power 2x. This is the solution for the given equation. As per the discussions, solution is x square divided by 2 into e power 2x. Among the four options, option C is the correct answer. Okay, so option C is the correct answer for the given question. Okay, next we are moving into the next one. The next question to you guys. Yes, this is the next question. Particular integral of d square minus 4d plus 4 into y is equal to 2 power x. What we are discussing here? We are discussing about the e power ax format. So we have to convert this 2 power x in terms of e power ax. So the 2 power x is converted into e power ax format. How the equation is modified is equal to the e power ax. So coming to the discussion. Here e power ax, 2x is converted into e power x. How we are converting? 2 power x is equal to, okay, here exponential power log, exponential and log cancel, log of 2 power x, 2 power x, 2 power x. So 2 power x is equal to exponential power log of 2 power x. So exponential and log cancel, the same value, the value does not change. Again is equal to, we are taking this x in the front side as per the logarithmic procedure, e into x into log 2, x into log 2, the same value. Okay, again what we are doing here, we are replacing that into the e power log of 2, log of yes, e power log 2, log 2 into x. So the total equation is the same value. 2 power x is converted into e power x format. Here a is equal to constant, a is equal to log x, log 2. Log 2 is the a. So we have to replace the things here. Then the denominator is changed as per the given options. D square minus 4d plus 4 is written it as, here we know that d square minus 4d plus 4 is equal to d square minus 2, d square minus 2 the whole square, d square minus 2 the whole square is equal to. So the left hand side LHS is converted into d square minus to the whole power 2. Then right hand side e power 2 power x is converted into the e power ax format. So e power log 2 into x is the e power ax format. So the value is same, it does not change. So coming to the explanation here. Yes, as per the discussions here, a particular integral value, the particular integral is equal to pi is equal to, we know that 1 divided by f of d. F of d is equal to d minus 2 the whole square into e power log of 2x, e power log 2 into x, log 2 into x. So what we are doing here, the coefficient of x is the log 2, that is a. So we are replacing the letter d by log 2. So it's equal to 1 divided by, instead of d substitute log 2, log 2 minus 2 the whole power 2 into e power log 2 into x. So here coming to the options, compare this option, the four options. So correct answer is option A. So option A is the correct answers. 1 divided by log 2 minus 2 the whole square into e power log 2 into x is the answer for the given question. Yes, so option A is the correct answer. Option A is the correct answer for the given question. Okay. Next we are moving to the next question. Okay, learners, if you are having any doubt, okay, you can comment your doubts in the live chat. Okay, before moving to the next question, okay, myself Sathyamoorthy, verified plus educator in the Unacademy platform. Install the Unacademy learning app in your Android mobile phone and open the Unacademy learning app. Search my name in the search bar Sathyamoorthy space V and follow me in the Unacademy platform. Then you get notified for each classes, the special classes as well as regular classes in the Unacademy platform. The special classes are free for everyone, you can watch it. Okay, so please follow me in the Unacademy platform. The next question to you. Yes, this is the next question for you guys. The solution of the differential equation is, this differential equation is 4 into d square minus 4d plus 1 into y is equal to 0. In the previous case, they asked about the particular integral. Here, the solution for the differential equation. So both the LHS as well as RHS. We need to identify the both LHS as well as RHS. We know that the solution for the LHS is complementary function and solution for the RHS is equal to particular integral. First, we need to identify the complementary function. Here, the complementary function. Coming to the complementary function, CF, the CF for the function. What we are doing here, we are replacing the d square by m square here. For the auxiliary equation is given by the auxiliary equation. The auxiliary equation is 4 into m square minus 4 into m plus 1 is equal to 0. So this is the condition. From this value, we have to identify the value of root values here. Okay. Then minus b plus or minus m is equal to, we know that minus b minus of minus 4 plus or minus root of b square. B square is equal to minus 4 square. 16 minus 4 is equal to 16 divided by 4. 2 into a, 2 into 4. So here the answer is minus of minus 4 plus or minus 0 divided by 8. So for the second order differential equation, there are two root values. So here the root values is given it as m1 is equal to m2 is equal to 1 divided by 2. So the complementary function, when the roots are m1 and m2 are equal value, then real value, it is real value as well as equal. M1 and M2 are real and equal. For this real and equal category, the complementary function is given by, this is the complementary function for the roots are real and equal category. The roots are real and category, M1 and M2 is equal value, then Ax plus B into e power mx. Ax plus B into e power mx. Here mx, m is the root value. Here for the given question is m is equal to 1 divided by 2. So coming to the equation here, the complementary function is given it as CF is equal to Ax plus B into e power mx. Into e power mx is equal to e power 1 by 2, e power 1 divided by 2 x. Then particular integral, here we need to identify the particular integral. We are for the constant value, we are discussing about the cases. There are different cases for the equation is, these are the different cases. We are having RH is equal to 0, either RH is equal to 0, e power x, sin ax and x power n. But in the given question is constant value 4. So we does not have any constant value in the RHS side format among the 8 cases. So we have to convert the constant value into the e power ax format by substituting e power 0x. The constant into e power 0x format. Coming to the equation here, complement particular integral. The particular integral is given it as, first we need to identify the change the right hand side into the right hand side is equal to e power ax format. So 4 into e power 0x is equal to 4. 4 into e power 0x is equal to 4 because e power 0 is equal to 1. So this is the procedure. So coming to the particular integral solution, Pi. Here Pi is equal to 1 divided by f of d. 1 divided by f of d is equal to 4d square minus 4d plus 4 plus 4 into 4 into, okay, in this equation, into 4 into e power, plus 1 plus 1 into 4 into e power 0x. The procedure is, we have to replace the letter d by 0. When you are replacing the letter d by 0, 1 divided by 0 minus 0 plus 1 into 4. E power 0x is equal to, so particular integral is equal to 4. The complete solution is, we know that the complete solution for the differential equation is the addition of complementary function as well as particular integral. The complete solution of the given differential equation y is equal to complementary function plus particular integral. Here we have calculated the complementary function as well as particular integral for the given problem. So coming to the complementary solution plus particular integral. Wait a minute here. Yes, the function y is given by, the solution y is equal to complementary function plus particular integral plus p cf plus pi. This is the equation. We know that cf is equal to ax plus b into e power 1 by 2 into x plus particular integral is equal to 4. From this equation, here particular integral is equal to CF is equal to particular integral is equal to this value. Okay, then complementary function. Particular integral is equal to plus 4. So when you are adding these two values, so correct option B. Coming to the options, option B is the correct answer for the given question. Ax plus b into e power 1 by 2 into x plus 4. Okay, is it clear to you guys? Okay, learners, those who are in the live chat, okay, you can ask your doubts here. I'm here to help you guys. The next question, please follow me in the Unacademy platform. Okay, Sathyamoorthy space B in the Unacademy platform. Type my name Sathyamoorthy space B in the Unacademy learning app. Then follow me. Then you get notified for each time for the special classes as well as plus courses. The next question to you is here. The same procedure what we did in the previous problem. The particular integral of d square minus 4 into y is equal to 1. The particular integral of d square minus 4 into y is equal to 1 is the, okay, what is the particular integral value? We know that the particular integral pi is equal to 1 divided by f of t. F of d is equal to d square minus 4. We are converting this 1 is equal to e power ax format. 1 into e power 0x. So e power 0x is equal to 1. So 1 into e power 0x is equal to 1. And e power 0x. The value e power 0x. This is the procedure. So substitute 0 instead of letter d. So 1 divided by 0 minus 4 into e power 0x. So it is answer is minus 1 divided by 4. The correct option is option B is the correct answer for the given question. Yes, option B is the correct answer for the given question. These are the methodology and procedure used here. The next question to you guys. Here, the particular integral of d square y divided by dx square minus 4y is equal to e power 2x plus e power minus 4x is. Okay, here the correct option. Okay, we are going to derive the differential equation here. There are two conditions are there, e power 2x plus e power minus 4x. So there are two particular integrals are there for the given question. Here pi is equal to given it as particular integral pi1 plus pi2. pi1 plus pi2. Condition here used for the differential equation. The left hand side we have to replace the d square y divided by dx square is equal to capital D square into y. The LHS side is given it as the LHS left hand side is equal to d square y minus 4y. So here d square y divided by dx square, d square minus 4 into y is the LHS side. The particular integral pi1, as per the discussion, pi1 is given it as pi1 is equal to 1 divided by f of d, that is f of d is equal to d square minus 4 into e power 2x into e power minus 2x. So as per the formula here, then we have to replace the d square by 2. We are replacing the d square by 2 here. D square is equal to 2 square minus 4 into e power 2x. We are replacing this equation is equal to 0. Denominator is equal to 0. Ordinary rules fails. Then again we have to multiply x in the numerator. Then substitute differentiate the f of d one time with respect to the d. So d square is equal to 2d. into e power 2x into e power 2x. This is the procedure here. Now, 1 divided by d stands for the integration. Then integrate the pi1 x into e power 2x divided by 4. X into e power x into e power 2x. X into e power 2x divided by 4 for the pi1. This is a particular integral 1. pi1 is equal to x into e power 2x divided by 4. The next one pi2, the particular integral 2. The pi2 is given as pi2 is equal to 1 divided by d square minus 4 into e power minus 4x. The replace the letter d square by 4. So minus 4 square is equal to 16. Is equal to 1 divided by 16 minus 4. 1 divided by 16 minus 4 into e power minus 4x. The 1 divided by 16 minus 4 is equal to 12. So e power minus 4x, e power minus 4x divided by 12. So pi2. Then pi1 plus pi2 is given it as, the pi1 plus pi2 is equal to pi, particular integral is equal to x divided by 4 into e power 2x plus e power minus 4x divided by 12. E power minus 4x divided by 12. So this is a solution. So as per the final derivation, the option A is the correct answer for the given question. Option A is the correct answer for the given question. Yes. Next we are moving to the next question. The next question as per the e power ax format. Coming to the e power ax format. Yes, the last practice question in the category of e power ax. The particular integral of d square minus 1 into y is equal to e power x plus 1 the whole square is. Okay, what about the answer for the given question? Here coming to the explanation for the given question. E power x plus 1 is given it as per the equation. It is given it as e power x plus 1 the whole square is equal to e power x the whole square is equal to e power 2x plus a square plus b square is equal to 1 plus 2ab, 2 into e power x. So these are the category. Now we are having two values here. What we are doing here, we are discussing this thing one by one. It's like a e power 2x plus 1 into e power 0x plus 2 into e power x. So these are the categories we are using here as per the discussions. Coming to the discussion, there are three values pi1 plus pi2 plus pi3. The pi1 is equal to 1 divided by d square minus 1 into e power 2x into e power 2x. Here we have to replace the letter. The letter D is replaced by number 2. We are replacing the d square by 2. What we are getting here? 1 divided by 2 minus 1. 1 divided by 2 minus 1 into e power 2x into e power 2x is equal to e power 2x. Then pi2, the particular integral 2 is equal to pi2 is equal to 1 divided by into e power x, 2 into e power x. The replace the letter same value here. 1 divided by d square minus 1, 1 divided by d square minus 1 into 2 into e power x. Replace the value here. Instead of d we are replacing the 1, so is equal to 1 divided by 1 minus 1, 1 minus 1 into 2 into e power x. So 1 into 1 minus 1, it's 0, so we have to multiply the x in the numerator, then we have to differentiate the denominator one time. D square, when we are differentiating d square, we are getting 1 divided by 2d, that is equal to, the value is equal to, we have to differentiate one time here, is equal to x into divided by d square, differentiation of d square with respect to d, 2d into 2 into e power x. The integration of e power x is equal to, integration of e power x is equal to the same value here. The integration of, wait a minute, d square minus 1. So here the explanation for the given question is, we are integrating 2 into e power x. Is equal to, we have to integrate this term. We are integrating the e power x. What we are getting here? X into e power x. X into e power x. X into, wait a minute. Wait a minute, I'm sorry. Yes, as per the discussions here, the pi3 is equal to, pi3 is equal to a square plus b square plus 2ab, plus 2ab equal to 2 into a into b is equal to 2 into e power x. Here 2 into e power x, we are substituting the 2 into e power x here. We have to substitute the 1 instead of d. So 1 minus 1 is equal to 0. Again we have to differentiate one time, the d square minus 1. We are differentiating the d square minus 1, 2d. The differentiation of 1 is equal to 0. So 2d, 2 into e power x divided by 2d. The integrate one time, e power x divided by 1. So here we have to replace the letter. Wait a minute. Yes. Here the pi1 is equal to e power 2x yes, here is equal to x into e power x into e power x. Then one more thing here, the slight change in the pi1. Coming to the pi1, we have to replace the 2 instead of d square. Near d square, 2 power 2 is equal to, 2 power 2 is equal to here 4. So 4 minus 1, 3. So e power 2x divided by 3. So pi1, as per the discussions from the particular integral value, it's a pi1 is equal to e power 2x divided by 3. Then pi2 is equal to minus 1. pi3 is equal to x into e power x. Then add these three values, what we are getting here as per the discussions here. Then pi, particular integral, is equal to e power 2x divided by 3 minus 1 plus x into e power x. So minus 1 plus x into e power x, we are getting the option 1 in the option A. So option A is the correct answer for the given question. Okay, as per the discussions. Okay. Next we are moving to the next case. The case 4. Okay, we had a discussions about the case 2. Next one we have to discuss about the case 3 and 4. Coming to the case 3 and 4, we have completed the e power ax format. Then we are moving into the case 3, that is RHS equal to sin ax or cos ax, the trigonometric form. The RHS side, if you are having the trigonometric function sin x or cos ax, okay, then what is the procedure? So coming to the explanation as per the particular integral, here when the sin ax or cos ax are there in the RHS side, right hand side, so 1 divided by f of d into cos ax or sin ax format, here we are replacing the d square by minus of a square. We have to replace the d square by minus of a square. So d square by minus of a square. In the denominator, d square is replaced by a square. Then we are going to discuss about the one problem regarding the sin ax and cos ax. Then we are moving into the multiple choice question. Okay. Yes. This is particular integral is equal to f of d 1 divided by f of d into sin ax format. In the sin ax format, find the particular integral of d square plus 4 into y is equal to cos 2x. We know that the particular integral is the solution of the solution to the RHS side. So here 1 divided by f of t into cos 2x, f of t into cos 2x. Here what we are doing here, we have to replace the letter d square in the denominator by minus of a square. Here a is the coefficient of x, then 1 divided by d square is replaced by minus of a square. Here a is equal to 2 as per the discussion. Here minus of 2 square is equal to 4. So minus 4 plus 4, 0. The ordinary rules fails. When the denominator is equal to 0, ordinary rule fails. The particular integral is equal to x into 1 divided by 2d into cos 2x into cos 2x. Here when the ordinary rules fails, we have to multiply the x in the numerator. Then the f of d should be differentiated one time with respect to the t. So we are multiplying x here. The differentiation of d square is equal to 2d. The constant is equal to 0. X into 1 divided by 2d into cos 2x into cos 2x. So this is the condition here. Then next we are moving to the next case. As per the next case, here 1 divided by d stands for the integration as per the previous problem discussion. So previous procedure, here 1 divided by d stands for the integration operation, integral operation. So the 1 divided by d, we have to integrate the given term one time with respect to the x. So cos 2x is integrated with respect to x. So it's sin 2x divided by 2. Cos 2x divided by, when you are integrating the cos 2x, sin 2x, then coefficient again the denominator divided by 2. So x into sin 2x divided by 2 into 2, 4. So this is a particular integral for the given differential equation as per the sin ax or cos ax format. We are going to discuss one more problem regarding that. The next problem here, find the particular integral of d square plus 1 into y is equal to sin x, into y is equal to sin x. The particular integral, again the solution of the RHS is the particular integral. So coming to the particular integral, 1 divided by f of d into sin x, 1 divided by f of d into sin x, here 1 divided by d square plus 1 into sin x. We have to replace the d square by minus of a square. Here a is the 1, the coefficient of x is equal to 1. So we are replacing the d square by minus of 1 square, minus of 1 square. So minus 1 plus 1 is 0. The denominator is equal to 0. When the denominator is equal to 0, the ordinary rule fails. So condition is ordinary rule fails. As per the ordinary rule fails condition, Okay, what we are doing here, the particular integral is equal to, again we have to multiply the x in the numerator, then denominator should be differentiated one time with respect to the d. So 2d, 1 differentiation 0, then 1 divided by d stands for the integration. We have to integrate the x with respect to sin x with respect to the x. So integration of sin x is equal to minus cos x. So minus x into cos x divided by 2. This is a particular integral of the given differential equation. Okay, I hope it's very clear to you guys. Then next we are moving into the multiple choice questions based on the sin x or cos ax, sin ax or cos ax format. Here, these are practice questions to you. The particular integral of d cube y divided by dx cube plus 4 into dy divided by dx is equal to sin 2x. Okay, what about the answer for the given question? Okay, the answer for the given question is given by here. The solution, we know that again we have to replace the d cube y divided by dx cube by letter capital D cube. So capital D cube into y plus 4 into dy divided by dx is replaced by capital D into y is equal to sin 2x is equal to sin 2x. Then take the y commonly from the equation. So d cube plus 4 d cube plus 4 into y is equal to sin 2x. The particular integral, we know that particular integral is equal to pi is equal to 1 divided by f of d, that is d cube plus 4 d cube, sorry, d cube plus d d cube plus d into y. So we have d cube plus 4d into sin 2x into sin 2x. Here we are taking the d commonly to convert the denominator into d square format, d into d square minus, sorry, plus 4 into sin 2x into sin 2x. When you are replacing the d square by minus of 2 square, so 1 divided by d into minus of 2 square is equal to minus 4 plus 4 into sin 2x. So here denominator is equal to 0. The denominator is equal to 0. So ordinary rules fails. What we are doing, we have to multiply the x with them. We are multiplying the x in the numerator. Then denominator, the previous one. The denominator d cube plus 4d is differentiated one time with respect to the d. When you are differentiating the d cube, 3d square plus 4. Here 3d square plus 4. Sorry, the numerator x. So x divided by 3d square plus 4 into sin 2x into sin 2x. Here we have to replace the d square by minus of a square. So x divided by 3 into minus of 2 square plus 4 into sin 2x into sin 2x. So here the minus of x divided by minus 4 into plus 3 minus 12 plus 4 into sin 2x is the solution. Now minus 4 plus 8 minus 12 plus 4, so minus 8 minus x divided by 8 into sin 2x into sin 2x. So this is the solution for the given equation. Minus x divided by 8 into sin 2x is the solution. So okay, coming to the options, minus x divided by 8 is the option, divided by option D is the correct answer for the given differential equation. Okay, these are the discussions about this sin ax or cos ax. Okay, thank you guys, thank you so much for the interaction. Please follow my name, Sathyamoorthy space B in the Unacademy learning app. Follow me, then you get notified for the each special classes as well as plus courses. Okay, please stay tuned in the YouTube live session, and again next session we are going to discuss about the differential equations part 4. Thank you.